Welcome to our mathematics class. This is part 5 of our basic examples using trigonometric functions. We will look now at example 5. We are given a diagram that is shown aside. Now we are requested to determine the value of each of the below. 1, sine theta, 2, cos theta, 3, 6 squared theta minus tan squared theta. Now let us look at the solution. We know that we are provided with the coordinates of A, which are 2 and 3. So from these coordinates, we can be able to determine the other side. That means the y value of the coordinates maps to the opposite side, which is side AB, to give it 3 units. The x value, which is 2, maps to the adjacent side, which is side OB, and therefore we have an unknown side, which is the hypotenuse. We need to calculate the unknown side first before we can do any calculations of what we are requested to calculate. The hypotenuse side is unknown. We can use the Pythagoras theorem to be able to calculate it. And the Pythagoras theorem states OA squared is equals to AB squared plus OB squared. OA squared would equals to 3 squared plus 2 squared when you substitute the given values for AB and OB. So OA squared equals to 9 plus 4 when we apply our knowledge of exponents. And as a result, we say OA squared equals to 13. And then OA is equals to root 13. Therefore, the hypotenuse side is root 13 units. Now, let us determine the value of sine theta. And we can do that by drawing from our diagram, which is updated with the hypotenuse being root 13. Sine theta equals to opposite over hypotenuse. Our opposite side is 3. The hypotenuse is root 13. So this becomes 3 over root 13. Number 2, we are requested to determine cos theta. The same way we can draw our values from the diagram, which is updated. Now, cos theta is adjacent over hypotenuse. So the adjacent side is 2 units. The hypotenuse is root 13. So as a result, cos theta is equals to 2 divided by root 13. And finding the last one, 6 squared minus tan squared theta. Let's also use the diagram as our source of information. So 6 squared, 6 is the same as hypotenuse over adjacent, and since it's squared, it will become hypotenuse over adjacent squared. And tan theta is opposite over adjacent, so tan squared theta would be opposite over adjacent squared. Substituting the values for hypotenuse, we substitute root 13, for adjacent we substitute 2, and for the opposite we substitute 3. And that results in 13 over 4 minus 9 over 4. And when we apply our knowledge of fractions, we get 13 minus 9 over 4. And that gives us 4 divided by 4, which is a 1. And that concludes the example number 5. I'm looking forward to seeing you in the next lesson, which will be dealing with the use of calculators in trigonometry. Enjoy the day and have a pleasant day.